On your TI-Nspire handheld, create a new document and insert the Graphs application. A suitable context for the table option is to compare taxi and rideshare costs. Suppose a taxi has a flag fall of $4.20 plus $1.60 per kilometre. The equation for the taxi fare would be y equals 4.2 plus 1.6x. A rideshare company has a call-out fee of $6.80 and $1.50 per kilometre. The rideshare equation would be y equals 6.8 plus 1.5x. If we are interested in distances up to 30 kilometres, then we need to adjust the window settings. For that sort of distance, we'd expect a fare of approximately $50. The graph shows the relationship between price and distance for the two options. Press Ctrl followed by T to display a table of values. We can scroll through and see the taxi fare in 1 kilometre increments. Arrow across to see the rideshare table. We could adjust the column width to see the comparison of the two, or put the table on a separate page by pressing Ctrl followed by 6 to ungroup the graph and table. Navigate to the next page. Now we can see both sets of prices side by side. To turn the table off, press Ctrl followed by T. Another way to explore the fares is to use the Trace option. Press Menu, select Trace, followed by Graph Trace. Use the left and right arrow keys to move along the graph, and use the up and down arrow keys to navigate between functions. To jump to a specific value, simply type it in using the keypad. You can also adjust the step increment by pressing Menu, select Trace, followed by Trace Setup. You can do a comparison of two fares by selecting Trace All. Now let's move away from taxi fares and consider a projectile. Suppose the projectile has the equation negative x squared plus 17x plus 18 all over 18. The projectile's path is in the first quadrant. I'll use the Trace option again. This time we see key features of the graph appearing automatically. We can see the y-intercept, the maximum, and of course the x-axis intercept or 0. The projectile's motion can also be represented as the parametric equation. I'll say x of t equals 9t and y of t equals negative 4.5t squared plus 8.5t plus 1. Suppose the projectile is a football and a player is chasing after the ball. The player runs at a speed of 6 meters per second but starts 4 meters ahead of the ball when it's kicked. Let's see if the player is able to mark the ball. The graph shows that the player definitely crosses paths with the ball. However, we can do a path plot to see if the ball and player are in the same place at the same time.